Welcome to Tuesdays with Trailblazers, brought to you by TechEdge AI, the video podcast where we bring you the latest trends and insights in AI and technology. I'm your host, Sadesh, and today we are hosting Kanish Chauhan, Senior Principal Analyst at Gartner. He has a wealth of knowledge in semiconductors and electronics. His core areas of research include display and optoelectronics. So without further ado, let's welcome Kanish. Hey Kanish, how are you doing today?
Very good, Sid. Thank you for having me here, first of all. It's a great opportunity to speak with the audience.
Likewise, Kanish, I'm really excited to see, what are some of the insights we actually get today. So diving deep in, I'd love to more about your journey in the semiconductor space. I guess there's pretty much a decade of experience out there, so we'd love to know more about it.
Absolutely. So my journey in the semiconductor industry was nothing less than an accident. So I am a mechanical engineer by education, and when I started working, I got an opportunity to work with the European Investment Bank.
Mhm.
So I was a part of their offshore team assisting European analysts to cover semiconductor stocks. So that's where I started building my knowledge, knowing all of those companies, learning their business, how they earn, what they make, etc., etc. So worked with that investment bank for close to 2.5 years. Then I moved into market research, hardcore market research. Worked across various organizations covering the industry, and unfortunately, that was not a time, not the best time to be in the industry. Nobody knew what semiconductors are. Nobody cares. Nobody cared what semiconductors do, etc. Unless until I would say 2021, when the semiconductor shortage started, and semiconductors were the talk of the town.
Mhm.
That's where we got our much deserved attention as the semiconductor industry in whole. I'm specifically talking about India because India was again a country where semiconductors was a very, very unique subject. I had a very hard time explaining to my friends and family what I exactly do. So yeah, that's more or less about my journey. Close to 10 years now, covering different aspects of the semiconductor supply chain. And yes, yeah.
Okay. That's crazy. I mean, not my wildest imaginations I could believe an investment banker turned, into the semiconductor space. I mean, that's a major jump, but
Yeah, yeah,
that's something I believe engineers are possible of, right? We're possible of.
absolutely.
Perfect. So, Kanish, there's a lot of noise around, India's semiconductor mission. And, there's this collaboration between the US Department of State and India's semiconductor mission. So how do you think it'll impact the global semiconductor supply chain, particularly in terms of, innovation and market expansion?
See, to understand the impact of this partnership, we need to take a closer look at the structure of these partnerships. This particular partnership between the US state government and the ISM will benefit by a special fund called ITSI. It is the International Technology, Security and Innovation Fund.
Mm-hmm.
Now, the total outlay of this fund is approximately $500 million, and which is about 100 million per year over a period of 5 years. The aim of this fund is, number one, to ascertain supply chain security and diversification. Number two, promote the development and adoption of secure and trustworthy telecommunication equipment. Now, clearly, the intention of this partnership is to eliminate any sort of dominance, specifically in the area of telecommunication and networking. Dominance in terms of one vendor, one country, and one region. Now, the fund itself is not sizable enough to result in any tangible outcome. Why do I say so? Because a semiconductor fab or any sort of semiconductor investment usually runs in billions of dollars. And here we are talking about $500 million
Mhm.
spread across 5 years. And this is a global fund. So India is not the only beneficiary. So to sum up, yes, the fund is not sizable enough to have any tangible outcome, but yes, I think they want to assess the existing semiconductor ecosystem, manpower availability, infrastructure availability in India. And the ISM, India Semiconductor Mission, will steer this analysis. And the outcome of this analysis would be, again, new partnerships. So it's a very, very baby step in a direction where we might see more collaborations and more partnerships with the US Department of State. But yes, no, nothing fancy or nothing tangible coming out as yet. I don't see it.
Sounds very interesting, and I believe it's a good start. Now, the next question I have is a follow up to this one. So, what do you believe are the key objectives of the US India partnership in advancing the semiconductor ecosystem? So, how might it influence geopolitical dynamics in the technology sector?
Right. Now, let me tell you a very interesting story here. We all are aware of semiconductor shortage because we couldn't buy our favorite phones, we couldn't buy our favorite PCs, gaming consoles and cars. Nothing was available at that time. What led to that situation? It wasn't just one single incident that led to the semiconductor shortage situation. It was a series of multiple events that happened over a period of time. So put that into a time frame. Let's go back to first quarter 2019. We were in a chip surplus situation. Surplus is a situation when the chip inventory throughout the supply chain is greater than the demand. So 1Q19, we were sitting in a surplus. That was the time when the US and the China trade disputes were sort of going further north. So US put a lot of restrictions on Chinese companies, specifically Huawei. It sort of crippled Huawei overnight. And as a result, a lot of Chinese companies were expecting a similar fate. So suppose you are a Chinese smartphone manufacturer, you were surrounded by a fear that you will not be able to cater to your customers because you won't be able to buy the latest processor from Qualcomm or any other chipset manufactured by any US company. So that led to a lot of panic buying. Huawei was put on the sanction list, but there were a host of other Chinese companies that were recklessly buying whatever was available in the market. This was second quarter of 2019. We moved into third and fourth quarter of 2019. 5G was also launched in different parts of the world. When 5G launched, chip consumption was increasing several folds. Then we entered 2020. 1Q20 was the time when lockdown was imposed in several parts of the world. Everybody expected that the market would, simply not exist. Nobody would buy phones, nobody would buy laptops during the pandemic, but the exact opposite happened. Because of the work from home, study from home, we now needed multiple laptops in a single household, multiple smartphones. People had a lot of spare money to spend. A lot of money was spent on gaming consoles. Everything was out of stock. Gaming PCs. Just think of anything and it was in shortage. And that gave a reality check to the market. While several factors accumulated together to cause this situation, but everybody was counting on a handful of companies to come out of it. Those companies were basically the fabs. I'm talking about TSMC in particular. It holds almost 60% of foundry market share. So basically countries like Taiwan, Korea, and China were tasked with coming, the responsibility of coming out of shortage was absolutely handed over to them. Countries realized that it's not the best way to go about it because chips are needed everywhere. Our defense system depend on semiconductor chips. Our telecommunication depends on semiconductor chips. And if some country decides someday to, to stop, basically throttle the chip supply, the country could come down on its knees. That's when the attention started towards indigenous manufacturing. CHIPS Act came in 2022. It was rolled with a similar, motive to encourage local manufacturing in the US. The Indian Semiconductor Mission was also formulated around, it started pitching in very aggressively around the same time frame, 2022, 2023. That's when all of these semiconductor incentives for fabs, displays, etc. were announced. And it wasn't just India and the US. The Europe also proposed a lot of facilities for companies who were thinking to set up chip manufacturing in the Europe, and that's how it began. So ultimately, the entire intention was to diversify the global supply chain, and that's where this
Mhm.
partnership is headed.
I mean, a lot of insights I could pick out there, particularly about I'm personally faced by DSMC's growth.
Yeah.
I know about their founder, started with Texas Instruments, all the way up to Taiwan, built TSMC, and now it's gonna be the next $1 trillion company out there. So personally faced by that as well. But yeah, I'm really keen on understanding, how this partnership between US and India in the semiconductor space actually pans out. So
Yeah.
next about, something that we're all excited about, Semicon India. In what ways is Semicon India 2024 expected to shape the future of electronics manufacturing in South Asia? And what sort of major announcements or collaborations might emerge from the event?
Last time I checked, I think there were 270 exhibitors who enrolled to Semicon India.
Mm-hmm.
The vendors include not only chip vendors, semiconductor companies, but all sort of providers. So there were equipment providers, providers of specialized machinery, which might be used for semiconductor manufacturing, consulting services providers, manufacturers of end-use devices. The list is diverse. So all in all, events like this attract participants and exhibitors from across the globe. A lot of international companies like Micron also attended the event, and it's a big thing, drawing attention of these larger corporates to India.
Mm-hmm.
It simply is something that has never happened in the
Mm-hmm.
past. Bringing all of these vendors together under one roof offers numerous opportunities for collaboration, investments, and networking.
Mm-hmm.
Now, consider this: you have to move an elephant. You call your friends, you call your families, you call everybody that you know. I'm sure, together, collectively, you will be able to accomplish something. So
Mm-hmm.
sometimes it's not about tangible outcomes. So Semicon India just wrapped up, I think, a month back, but
Mm-hmm.
we haven't heard of any tangible outcomes. But it's also providing the right environment, bringing everybody under the same roof. Getting media attention,
Mm-hmm.
showing that some work is being done. I think it goes a long way.
Perfect. So now talking about India's growing role in the semiconductor industry, Ganesh, these
Mhm.
are highlighted by initiatives like Semicon India 2024. How do these contribute to
Correct.
these ambitions to become a global hub for electronics manufacturing?
Right. So, what do we have until now in terms of semiconductor manufacturing? One fab, which is announced by Tata,
Mm-hmm.
two ATMP facilities, one by Micron, other by CG Power, and the other one is OSAT, which is again by Tata.
Mm-hmm.
Another fab proposal, which is currently under review, is from Adani Group and Tower Semiconductors.
Mm-hmm.
So, all in all, these are the some big ad- advancements towards indigenous semiconductor manufacturing that we know today.
Mm-hmm.
None of these developments have anything to do with Semicon India. They were announced, most of them were announced much before Semicon India. But yes, I know a lot of industrial machinery makers,
Mm-hmm.
industrial vacuum pump manufacturers who attended the event. I know automation equipment vendors who attended.
Mm-hmm.
I know others who are remotely linked to semiconductor manufacturing attending the event.
Mm-hmm.
Now, these vendors play a very important role when fabs are built, because
Okay.
when fabs are built, need all of these equipment in very large amounts, in very large scale. It's not ideal to import all of these small, ancillary equipment, because you need somebody to keep them running. You need maintenance folks, you need support folks, and it's not ideal to import all of these from other countries, because of course you need a local repair and local maintenance. So yeah, do you understand the two sides I'm looking at? On one side, there's no tangible outcome to a direct a fab announcement directly, but yes,
Mm-hmm.
uh, we are creating an atmosphere, we are creating awareness that all of these ancillary equipment producers, or folks who support the semiconductor, who have the potential to support Indian semiconductor manufacturing, do exist locally.
And do you anticipate this happening in the next 5 to 10 years, or would you think that might take more time for us to become a global hub?
To become a global,
Hub for electronics manufacturing.
see, we are already doing great in terms of electronics manufacturing. So all of these smartphones, all of these TWS headsets, these tech companies, companies like companies like Bolt, and all of these recently emerged companies are doing pretty good in India.
Mm-hmm.
So on one side, we have electronic manufacturing. Now these companies do import majority of their in fact, most of their components and PCBs that are required for these products. Now, the situation is totally opposite when we look at the semiconductor manufacturing.
Mm-hmm.
In semiconductor manufacturing, the biggest challenge for India is to provide a proof of concept. Until now, we haven't been able to, show the world that a fab can successfully run in India.
Mm-hmm.
So when that happens, only after that happens, we will be able to predict a timeline. Let's see, because the Tata Fabrics is successful in Dholera.
Mm-hmm.
In next 5 to 7 years, we might have three more fabs to accompany that one. So we need some sort of ice breaking happening there for sure.
Mm-hmm. Got it. Got it. So, last question. This is my personal favorite one. So, what are the challenges and opportunities do you foresee for the Indian semiconductor industry, as it deepens its collaboration with international partners like United States?
So like I said, I'll just repeat my favorite sentence here. The biggest
Mm-hmm.
challenge for India is to provide a successful proof of concept.
Mm-hmm.
I'm not sure how correct it is to draw parallels here. However, look at the history of IT services in India. It
Mm-hmm.
started with a successful POC by TCS in 1974. Slowly, the industry evolved, and so did the economic policies to support the industry. And what we see today is a very successful implementation of that POC. I
Mm-hmm.
think this is not novel to India or IT services industry in particular. Any industry in any new region has to prove its feasibility. And
Mm-hmm.
once one vendor is brave enough to take that risk and prove to the world that it is the risk worth taking, others do follow. A
Got it.
semiconductor fab is a very big investment. Vendors are not aware of our economic policies, domestic market demand, political stability. Unless a vendor successfully opens a shop and becomes profitable, no amount of market research and consulting can help to prove this concept.
Mm-hmm.
Now, it took at least 20-25 years for the IT industry to evolve in India. So, it does it mean that the semiconductor ecosystem will take an equivalent time? I would say no.
Mm-hmm.
Don't forget that IT was also not mature in the 70s.
Exactly.
It started maturing in the 90s.
Mm-hmm.
So, but that's not the case with the semiconductor industry right now. Semiconductor industry is at its peak right now. Technology is available today. We just have to scale to grab that opportunity.
I've actually read the story about TSMC and how a
Mm.
small country like Taiwan is actually, contributing what, 60% to the entire
Yeah,
semiconductor
almost
space in the
60%.
world.
Yes.
So what do you think like these countries do differently and a mammoth country like us is failing to do that? Is it initiatives from the government side that is making sure that we have our own shortcomings? What exactly do you see a difference?
I think it's a mix of all the things. So, being at the right place at the right time, taking the right decisions, and having policies that support and nurture these initiatives.
Mm-hmm.
So, you are amazed by the example of TSMC. Let me give you another example. Let us
Mm-hmm.
talk about the display industry.
Mm-hmm.
So, display was, all of the displays that we use today in our PCs and our laptops, everywhere in our TVs. It was basically liquid crystal display, LCD,
Yeah.
a technology that was dominated by Korean manufacturers, LG
Mm-hmm.
display, Samsung display, and there were folks, others as well. Japanese manufacturers such as Sharp, Sony, clear dominance there. It was a low barrier to entry market comparatively compared to semiconductor manufacturing. China totally crushed it.
Mhm.
How did they do it? So they not only helped their own companies to start panel manufacturing locally. They helped in R&D. They invested a lot in R&D. Then they also helped in selling those products. So I'm because I also cover LEDs, which is again a market dominated by Chinese vendors.
Mhm.
I am aware of situations where all of these companies were selling their products in losses, and the Chinese government was subsidizing them for a very, very long time. It helped them to kill the competition, completely destroy the competition. Samsung shut its shop for LCD manufacturing, so did LG, and so did a lot of other Japanese companies. Ultimately, it wasn't feasible for all of these vendors to compete with the Chinese dominance. And that's what they're repeating again with OLEDs, the latest display
Yeah.
technology uh, that we are looking at. So see, there could be two market landscape. One is
Mhm.
the technology is very, very emerging. You take the boat early on, you devise policies, and you basically create an ecosystem to nourish and nurture that journey. And the other thing is when you're late to the entry, you have to destroy it by aggressive
Exactly.
investment. Right now, we are in a situation where we need aggressive investments. And unfortunately, that's not happening. If you compare the US CHIPS Act with the kind of support that Indian government has announced, just compare it. It's uh, I would say it's incomparable. Companies, semiconductor fabs, they demand a lot of money, especially the leading edge fab. It runs into multiple billions of dollars. 15, 20 billion dollars is what they require to,
Mhm.
for a company like TSMC to start manufacturing 3 nanometers, 5 nanometers, etc. So providing a mediocre support won't work in this.
Makes sense. So if I were to put it straight, I believe in order to win this semiconductor wars, we need equal support from the government. The government has to step up and make sure that, provide subsidies to companies which are coming up with semiconductor manufacturing, right?
So there could be two, way outs of it. One, India becomes a market which is lucrative enough for companies like TSMC that it do not want to miss the opportunity and they want to be here. It's missing India would be like missing an opportunity for them. Unless that is happening, we need very lucrative incentives to draw these companies to set shops here. You are a better judge. The first one is indeed happening, but it won't happen overnight. So we surely need very lucrative incentives.
Makes perfect sense. And everyone knows about, how the semiconductor space is going to evolve, it's how important it's going to be, how mammoth it's going to be. So, but what do you think, what's going to be the impact in the next couple of years? Let's say, for example, if we were to, hit a crystal ball and see the future in the next decade, what do you think we're looking at from a semiconductor space?
See, countries like the US are putting in a lot of money to have they basically care about, everybody basically care about the leading edge of the technology. So all of these, the technology at which these semiconductors are manufactured, it's
Mhm.
referred to as nodes. So anything below 6 nanometer is called as advanced nodes, and anything larger than 6 nanometer is there are different other sizes as well, but broadly categorized as legacy nodes. Not exactly 6 nanometer is not legacy; it's also advanced. But yes,
Mhm.
to give you some context, anything below 6 nanometer is of prime importance to these countries because AI processing, memory, everything revolves around these leading edge, and that's what they want to control because that's where number one supremacy in technology lies. They want to be the number one in AI manufacturing, AI processor manufacturing. Everybody wants to be the number one in memory. Nobody wants to make an analog power chip
Mhm.
at this point in time. So, 10 years down the line, if you ask me, I see developed countries aggressively expanding their capabilities, including China, to develop all of these leading edge chips. And emerging countries in the semiconductor ecosystem, like India, like Vietnam, Taiwan is also becoming a hotbed. So all of these countries would support, the broader equipment market in terms of other chips, which are not very critical to national importance, I would say. So things like analog chips, power chips, maybe displays would be left out for countries like India and Vietnam, and maybe Taiwan.
Well,
So yes, leading edge is not where I would anticipate any major activity happening in near time.
got it. Perfect. So some wonderful insights out there, Ganesh, and I really enjoyed speaking to you. So it was an
Same
absolute
here.
pleasure hosting you on Tuesdays with Trailblazers. And thank you all for joining us today. If you enjoyed this episode, please subscribe and leave us a review. Until next time, stay tuned with TechEdge AI for more insights into all things AI and technology. Till we meet again, signing off, your host, Sadesh.